Hello, my name is Loren Sunding, and I will be discussing my senior project, an application of internal gearbox drivetrains for commuting-oriented bicycles. My project's technical advisor is Treon Giorgio. The agenda of this video is as follows: an introduction to go over current bicycle drivetrain options, a review of the project's problem statement, background information, and finally, my solution to the problem, as well as the expected deliverables of the project. Today's modern bicycle commuter faces many issues while riding to work, school, or while running errands. One of these issues is the reliability of bicycle drivetrains. Traditional cable-actuated derailleurs are exposed to the elements of city streets, including dirt, dust, and water. The derailleur's external positioning also serves to make it susceptible to damage from bicycle racks, accidents, or crashes. If not precisely tuned, derailleur systems can malfunction and result in inconvenience and can sometimes endanger the rider if the chain becomes jammed. Another drivetrain option available to bicycle commuters is the internally geared hub. Internally geared hubs move some of the necessary components of a multi-speed drivetrain into the hub shell. These hubs are readily available from several manufacturers, including Shimano, Sturmey Archer, and Rollov. Some of the shifting mechanisms for internally geared hubs are still mounted to the external frame of the bicycle and are not protected from damage or contamination. The final drivetrain solution currently available to bicycle commuters is the internal gearbox available from Pinion. Pinion's gearbox is of the highest quality but has drawbacks for a bicycle commuter. The gearbox is by far the most expensive option currently available on the market and requires a special frame for use. Now that bicycle drivetrain options have been introduced, I can reveal my problem statement. Current bicycle drivetrains available to commuters are not adequate for a carefree ride. The options are either unreliable, expensive, or unsafe. Bicycles are becoming an increasingly popular option for commuting in urban areas across America. Local, state, and federal governments have been increasingly investing in bicycle facilities, including parking racks and bicycle lanes. As bicycle infrastructure grows, more bicycles will be on the road, and a solution to drivetrain issues must be implemented. In order to fully understand the components that make up a traditional commuting bicycle drivetrain, this image will be discussed. The rear derailleur, pictured here, shifts the chain anywhere from the 5 to 11 gear options, depending on the model. A front derailleur, pictured here, shifts the chain on the front chain rings, which are attached to the crank arms. The rider is able to power the drivetrain by turning the crank arms with their feet. Although the derailleur has essentially run a monopoly on the bicycle drivetrain industry since the 1920s, there have been competitors throughout history. Internal geared hubs, such as the one patented by Shimano in 1964, have had sporadic use since their invention. The hub, which is powered by a typical roller chain, houses a planetary gear set, which allows the rider to change the gear ratio with a handlebar mounted selector. Geared hubs use planetary gears, which allow the input and output of the gearing to share a common axis. Planetary gears are rugged because 3 gears spread the load over the ring gear. My solution to this problem is a simplified 3-speed internal gearbox. I will attempt to design the gearbox so that it is attachable to any bicycle frame that utilizes a thread and bottom bracket. In order to solve this problem, the following steps will be taken. Perform background research to fully understand operation of available drivetrain options. Quantify variables of each drivetrain option, including efficiency, price, weight, and reliability. Design first prototype of solution using a combination of additive manufacturing processes and machined parts. Evaluate first prototype, modify and prepare design for production prototype. Manufacture design. Implement design onto a bicycle. Perform economic analysis on manufacturing processes.